Alright, so hello everyone. By now you've likely picked up on many specific details about fibroblast growth factor 2 or FGFR2, such as the Ig2 and Ig3 domains, as well as the presence of the disulfide bond that stabilizes the Ig3 domain. This video will cover other protein elements that are essential in the role of FGFR2 to provide you with a more complete understanding of its structure and therefore function. So let's begin by observing the structure of a standalone inactive or monomeric FGFR2 protein, which is this structure here if you ignore the green and white regions for now. As you can see, the Ig2 and Ig3 domains, shown in red and yellow, are bound to a fibroblast growth factor 1 or FGF1 ligand, shown in green. In addition, the heparin binding region, shown in pink, is bound to the heparin sulfate proteoglycan, showcased as that white stick model. As can be seen, a substantial portion of the FGF1 ligand is bound to the heparin binding site, which explains the role of this region in enabling FGF ligands to very tightly associate with FGFR2. And without this region, limited binding of FGF would occur to the protein, and therefore reduced or loss of function would be observed. The heparin sulfate proteoglycan, so this white structure here, on the other hand, has dual functions. So it can either directly bind to FGF ligands and inhibit them from binding to FGFR2 proteins, or it can do the opposite. It can promote FGFR2 dimerization by associating with another FGF ligands already bound to FGFR2, as showcased here. So that's another FGF1 ligand bound to an FGFR2 that this heparin sulfate proteoglycan associates with at that point there, and with this FGF1 ligand here. Therefore, mutations affecting the Ig2 domain, the heparin binding region, and heparin sulfate proteoglycan can also modulate FGFR2 function and lead to conditions such as Crouzon syndrome.